Hello, Math 142. Find equation of an ellipse with minor axis 10, foci on y-axis passing through square root of 5, comma, square root of 40. So notice that in this problem, since we have the foci on y-axis, I know that my major axis must be on the, it must be on major axis would be on y-axis or at least parallel to the y-axis. So here's x, and so this is the shape, the general shape of an ellipse whose foci is located on y-axis. So I don't know about you, but it's almost always easier for me to write down the form. So here I'm putting y in front, y squared over a squared plus x squared over b squared equals 1, because I have to remind myself that the value of this a, that a has to be greater than b. That's the key. Okay, let me go to the next page. So based on the information that we were given that the minor axis is 10. So 2b equals 10, and therefore b equals 5. And now I'm going to go ahead and use the given point. I know that this is my x coordinate, this is my y coordinate of that point. So I'm going to go ahead and substitute square root of 40 for y, square root of 5 for x, and simplify. Okay, I'll get 40 over a squared plus 5 over 25 equals 1. And I can simplify 5 over 25 in here to 1/5. And the goal is here to solve for a squared. So let me go to the next page. And so now I have 40 over a squared equals 4 over 5. And with the understanding that a cannot be 0, of course, a cannot equal 0 in here, but it has nothing, it has no bearing in our calculations. You can multiply both sides by LCD, or you can cross multiply. You'll get 200 equals 4a to the second, divide both sides by 4, and then you will get a to the second equals 50, and that's the information that we needed. So now I know that y squared over a squared in here plus x squared over b squared, that is 25 in here, equals 1 is our final answer. And remember, in the very first page, we found that b equal 5. So b squared must equals 25. Okay, let's do another example. In this problem, we are finding equation ellipse. What's given to us is eccentricity of 0.75. I don't feel comfortable working in these problems with decimals, so I'm going to change that to 3/4. And I've been given the foci of plus and minus 1.5 comma 0, and I'm changing 1.5 to 3/2. That's my habit. You don't have to, comma 0. So now the form is x squared over a squared plus y squared over b squared equals 1. How do I know that? I know because the foci in here, you see the x and the y tells me the value of y is 0, and I have two values, plus and minus 1.5 or 3/2 for x. So I know that foci is located on x-axis, or at least parallel to x-axis. And so I know that foci is always located on the major axis. All right. What else is given to us? The eccentricity is given to us. So I know E equals C divided by A. Let me go to the next page. Now, using the value of C was given as 3/2. The value of the value of E was given as 3/4. And in here, if I multiply the top and bottom of this by 4/3, so cancel, 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 cancel. And then you have cancel this, and 4 divided by 2 is 2. So, excuse me. So a squared equals 4. If a equals 2, then a squared equals 4. Let's keep that information. And I also know that c squared equals a squared minus b squared. Solving for b squared, I get a squared minus c squared. A squared is 4, b is 3/2, so I get 4 minus 9/4, which gives me 7/4. So therefore, my equation is x squared plus 4 plus y squared over 7/4 equals 1. If you don't like to have a fraction in the denominator, and if you multiply top and bottom by 4, okay, then I get x squared over 4 plus 4y squared over 7 equals 1. I really don't have any preference. It's just, it's up to you. Let's see, we have time for one more. Let me go to page 6 in here. Our final example is we are finding an equation on ellipse with eccentricity of √5/3, foci on x-axis. Okay, so this is clearly telling me that foci is on x-axis. And so the general shape of this ellipse is going to be something like this. Okay, and we are given that the length of minor axis is 12. So the minor axis is 12, and so my b should be half of that, which is 6. Okay, using this general format, let me continue. The 2a, or the size of minor axis, which is twice a, was given as 12. Therefore, a is half of that. That equals, and so half of 12 is 6. Once again, I know E equals C over A. The value of E was given to me in here as √5/3, and that equals C over A. And we found out that A equals 6. Okay, by cross multiplication, I get 3C equals 6√5. Divide both sides by 3, and I get C equals 2√5. So now that I have the value of C and I have the value of A, I'm going to go ahead and solve for the value of B using my general formula that C squared equals A squared minus B squared. By rearranging, I get B squared equals A squared minus C squared. And then let me go to the next page. So I have B squared equals 36 minus 2√5 quantity squared. 2√5 times 2√5 gives me 2 times 2 is 4, and √5 times √5 is 5, and 4 times 5 is 20. So B squared equals 16. Finally, I have x squared over 36 plus y squared over 16 equals 1. And I hope you find these examples helpful. And I apologize, I forgot to give the credit to Stewart, Redlin, and Watson, the authors of this textbook. These problems came directly from your textbook. Thank you.